Hi everyone, welcome to the 14th episode. So we have reached so far in our recursion series and there are few more episodes to go before we master recursion. Then we will pick up another topic, okay, in a similar way. Now before starting with this one, make sure that you give a like and a small comment to this video, because at the end usually you forget and then you go away simply without liking the video and then subscribing to the channel. So if you're new here, make sure that you subscribe as well. All right. Now we can start with the question. It is combination sum 3. We have already seen combinations. We have already seen combination 1, combination sum 1. We have seen combination sum 2. We have seen subsets. So all these problems are interrelated. If you haven't watched them, make sure that you watch. The list of prerequisite will be there in the description. Okay. Now, starting with this episode, we have seen that in all these kind of problems like subset, combination sum, we basically have to generate possible subsets, right? In the subset problem, we had to generate all the possible subsets, basically 2 raised to the power n number of subsets, where n are total elements and 2 raised to the power n are the total subsets. Now those subsets were of different sizes. Few of them were of size 1, then 2, then 3, ranging from 0 till n. There were subsets of different sizes, right? Then we also generated subsets of specific size. So let's say of size 4, we generated subsets of size 4. Then we also saw that how to generate subsets of a specific summation. Subsets having a specific summation. Number of elements, we are not bothered about number of elements there. We are bothered about the summation of those elements, right? But in this problem, we have to generate subsets where the number of elements should be equal to k and the summation of those elements should be equal to n. Okay, these two restrictions are given over here. Number of elements should also be equal to k. The summation of those elements should also be equal to n. These are the two restrictions given over here. We have seen these two restrictions individually in different questions, but now both these conditions are given in a same question. Okay, now we have to solve it. Also, what are the available numbers which are given to us? The available numbers which are given to us are from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so we are not given an array over here. We are not given anything else. We are just given that you are having numbers from 1 to 9. So we will basically handle it very easily with the help of just one integer I. We will be able to handle it. Okay, now let us see how we can draw the recursion tree. Then we will move on to the coding part. All right, so let us say we are given k as 2. This is the required number of elements. Sorry, this is the required number of elements. Then n as 5. This is the required summation. Now you are given elements from 1 to 9. You can consider that you are having an array which contains elements from 1 to 9, or maybe you can just consider that you have elements from 1 to 9. You don't even have to create that array. So I will be able to handle it with the help of just one integer I. So I will start with that integer I. Initially I is equal to 0. Sorry, I is equal to 1 because we are having numbers from 1, right? So initially I will be equal to 1. Okay, you will have a empty subset. Summation of that subset will be 0. Number of elements in that subset will be 0. Okay, now let us talk about the first element, which is equal to 1. So either we can take this one or we can ignore this one. So let us say we are taking this one. So if I'm selecting this one, my subset is going to become 1. Okay, I will become 2. Okay, the summation will become 1 and the total number of elements will become 1. All right, now if I ignore this, one, I will become 2. Okay, the subset will be empty, the summation will be 0 and the size will be 0. Now let us talk about this. Here also we have two options. One option to basically pick up the element 2. Second option is to ignore the element 2. So let us say we are picking up the element 2. So 1 comma 2 is the subset. I will be equal to 3. Then the size of the summation is 3. The size is 2. Okay. And if we are not selecting 2, subset will be remain same. Summation is 1. Size is also 1. I will become 3. Okay. So this is how we are going. Okay. In this also, if we select 2, subset will become this. Summation will become 2. Total number of elements will become 1. Okay. I will become 3. Here also I will become 3. the subset will remain empty, summation will be 0, total number of elements 0. Okay, so this is how the recursion tree is going to work. And what all are going to be the stopping condition? So the stopping condition would be, let's say we already have 2 elements in the subset. Now we cannot have any other element. Okay, we already have 2 elements, we cannot have any other elements, and we are given that we should select only 2 elements, not less than 2, not more than 2, only 2 elements, but also with the summation 5. Here we can see that there are 2 elements, but the summation is not 5, summation is 3. But we are going to stop here, we are not going to proceed from here. Why? Because if we proceed from here, what all options do I have? First option I will be having is to include this 3. Second option I will be having is to ignore this 3. So if I ignore this 3, obviously summation would not change. And if I take this 3, I will not be able to take it, because total number of elements will increase. It will become 3. Total number of elements will become 3. We already have 1, we already have 2. Okay, 3 will also come. So that is not allowed. Okay, we should stop at 2. When the size of subset becomes 2, we should basically stop there and check that whether the summation here is equal to n or not. As soon as the size of subsets becomes equal to the given size, we should basically stop there and check what is the summation till now. If the summation is equal to the given summation, save it and then return from here. If it is not equal, then simply return from here. You cannot do anything else. Okay, you already selected k elements. You already selected k number of elements. You cannot select any more element. And even after selecting k elements, if the summation is not equal to the required summation, return from here. If the summation is equal to the required summation, save the answer, return from here. Okay, this is the base condition. Other base condition would be when your I basically keeps on increasing and it becomes 10. Then you cannot select it. You're only given numbers from 1 to 9. Okay. So one restriction will be on I. When I becomes 10, you should stop and return from here. One restriction will be when basically the size of subset becomes equal to k, then we should stop and return from here. Okay, basically not stop and return. When size is equal to k, stop and see what is the summation. If summation is equal to the required summation, save it and then return. If it is not equal to the required summation, simply return. Other condition would be, there would be one more condition. So let's say the total number of elements which are allowed are let's say 7, and we only have 5 elements in the subset. It basically means that we can select 2 more, right? We can select 2 more elements. But let us say if the summation of those 5 elements itself exceeds the required summation. So for example, look at the board. Let us say this k was 7. So we were allowed 7 number of elements in the subset, and the summation was required. The summation was, let's say, 11. Okay, this was the required summation. Now you already have 5 elements in the subset. Those 5 elements are 1, 2, 3, 4 and 5. What is the summation? The summation would be 9, 10, 15. 15 is the summation, which already exceeded 11, right? So there's no point moving from here. When the summation is exceeding the given summation, the required summation, return. Okay, so we will just write down these points while we are coding it, and things will become much more simple when we start coding it. Okay, so let us go to the coding part, start solving this. So this is the problem statement, you can read it. So again, I would be having the same kind of function, void help int I, then int k is the total number of elements we need. Int sum, this is the summation till now. Okay, sum till now, let me name it as sum till now. And this is the required sum n. Then we will have a vector of int subset. Then we will have a vector of int answer. Okay, so as I told you, if this k, actually what I will do is, okay, let us write the base conditions later on. First of all, again we are going to do the same thing. For every element we have 2 choices. First choice is to basically pick the ith element. I am picking the ith element, which basically means that sum till now is going to get increased plus equal to I. Ith element here is I itself, right? Ith element is I, because we are not given an array here, we are not given a vector here. This I itself is acting as an element. Okay, all right, so I'm adding this, and then in the subset also subset dot push back I. Done. Now ask recursion to do rest of the task from I+1, and this k is the required number of elements, right? K is the required number of elements. Because we picked up the ith element, required number of elements will get reduced by 1. I will ask recursion to do rest of the task. And what is that rest of the task? Rest of the task is to basically find k minus 1 elements now. Okay, find k minus, because one element I have already picked. Now find k minus 1 elements. All right, so this is going to be k minus 1 instead of k, and then sum till now. Then we will have n, then we will have subset, then answer. Okay, now recursion will do its task. It will come back to line number 7, and at line number 7 we will undo these changes. These changes we are going to undo. So sum plus equal to I we did, so sum minus equal to I, then subset dot push back I, then subset dot pop back. Done. This is the backtracking step, and I have been putting a lot of emphasis on this particular line. This is backtracking, and you must not forget this, otherwise you will get wrong answers. Okay, so after doing this, let us ignore the ith element. If I want to ignore the ith element, first of all, if I'm ignoring this, I should not add anything to the sum till now. I should not put anything in the subset. I should simply ask recursion for the help I+1. Here k is going to remain same because I am not picking the ith element. Because I am not picking the ith element, this k is going to remain same. I will ask recursion to do rest of the task. And what is that rest of the task? That rest of the task is to select k elements, right? Select k elements. Okay, done. Then sum till now subset comma answer. One more thing I just want to mention over here is this k minus 1, we are basically reducing the number of elements which are required. You can even do it outside. K minus equal to 1, as we are changing this sum till now, right? We are changing sum till now outside this function call, right? So we can do the similar thing for this k minus equal to this. So we will not have to do it inside the function call, but because we are doing it outside, this, we will have to undo this change, k plus equal to 1, like this. Okay, otherwise just let it be inside this function. You can just think upon it, what am I doing here? Basically, if you are bringing this change outside this function call, right? If you're bringing this change outside, this disturbance outside this function call, you will have to undo this. You will have to undo this outside. Got it? But if you're keeping this inside, you will not have to do anything. Similar way we can do for this sum as well, right? Same thing we can do this for this sum as well. Instead of doing it over here at line number 4, just comment it out, and just comment out the undo part as well, and then you can add this like it. Okay, so you can do it like this as well. Okay, so yeah, but we basically avoid doing this, so just bring it outside. That is much more intuitive. Okay, that's it. I just wanted to show you that why do we have different kind of codes. Whenever you will see refer some other code, you will see people doing it in a shorter way. They will not first put it then undo it. Instead of that, they will just pass the change in the recursion. Got it? So it's okay to do both ways, but I prefer it doing over here. It makes the things very intuitive. Okay, all right, so don't get confused by it. It is just the syntactical thing. All right, so we are ignoring the ith element over here. Now if k is equal to 0, basically we picked up k elements. We were asked to pick up k elements. We picked up k elements. Now k is equal to 0, and all right, let us do it like this. If k is equal to 0, okay, we cannot take any more elements, so we will check what is the sum till now. If sum till now is equal to the required sum n, we got the answer. Answer dot push back subset. Done. We got the answer. Okay. Otherwise, if it is not equal to n, then in that case you did not get the answer. So if you did not get the answer, what should you do? You should do nothing, simply return. So simply return from here. Okay, simply return from here. All right. So if k is equal to 0, basically we cannot take any more elements, so we should stop and have a look at what is the sum till now. If the sum till now is equal to the required sum, then yes, save, this is one of the answer, otherwise simply return. One more thing, if the sum, let's say if we are not able to make k 0, as we saw in the example on the board, right, we are not able to make k 0, k is 7, we have only picked up 5 elements, 2 more elements we can pick, so basically k is 2, but the summation of those 5 elements itself is exceeding the required summation. In that case, we have to return sum till now. If it is exceeding the required sum, return. Got it? Return from here. One more thing we can do is if I is equal to 10, basically we started with 1 2 3 4 5 6 7 8 9. At 9 we should stop, we should not go beyond 9, right? So if it is equal to 10, then return from here. Okay, so basically these are the 3 base conditions. You can shuffle them up as well. So instead of checking k is equal to 0, what you can check is if the summation is equal to n. If the summation is equal to n, then make a check for k. So instead of doing this, first k is equal to 0, then checking the summation, you can even ignore this and you can do like this. If your sum till now is equal to n, okay, you basically made to your sum. Now if k is equal to 0, if it is equal to 0, you got your answer dot pushback subset. Okay, pushback subset, and otherwise return from here. Now one more thing, because you are making a check for n, basically, right, you are making a check for n here, you can make a check for k outside. If k is going negative, then you should stop. If k is going negative, then you should stop. So instead of making a check for n outside, you can make a check for k outside, right? So that's the change that you can do. So both these things are going to work. Let me show you with the help of the example. You can basically pause the video, have a understanding of what am I doing over here. So we have 2 conditions here. One is for the summation, one is for the number of elements. So if you want to focus on number of elements, if you want to basically stop when you have the required number of elements and then make a check for summation, it is fine, you can do that. Okay, stop when the number of elements is equal to the required number of elements and then make a check for the summation. Otherwise, what you can do is you can make a check for summation first. Make a check for summation. If you have the required summation, stop and then make a check for total number of elements till now, right? Okay, when you are making a check for the summation, then outside you should make a check for k, whether k is going negative or not. Okay, if k is going negative, then stop here. So these 2 things you can shuffle up. So if you are making a check for summation here, make a check for k outside. If you are making a check for k over here, make a check for summation outside. That's it, and one check will be for I. Now let us try to call this function help with 0 and k, and sum till now is 0, subset, we need to have a subset, then an answer. Let us create a vector of int subset and a vector of vector int answer. Okay, and finally we have to return the answer. Let us run this. There is some issue, cannot convert from vector. This answer is vector of int. This is a void function. The problem is in line number 27. I plus 1 k sum till now we should pass n, then subset, then answer. I hope. Okay, there's one more error. Vector to int line number 33, we should also pass n, k0 n, subset and answer, right? We are getting a wrong answer. Let us do a dry run over here. So this is the sample input. Let us take this sample input and see Where are we going wrong? So okay, we are starting with 0. We should start with 1 instead. We should start with 1, not 0, because we have numbers from 1 to 9, not from 0 to 9. Okay, so now we are getting correct answer. Let me run this again. It got accepted. Let me submit this. It got accepted. Now instead of making a check for sum till now equal to n, let us do a check for if k is equal to 0. Okay, and inside this, when k is equal to 0, then we will make a check for sum. Okay, here we did the opposite. Here we basically first check for the sum and then k is equal to 0. Then we should also change the first conditions. For the condition, other condition should be if n is going, if sum is going beyond our required sum, then we should stop. So this is the condition: when sum till now is going beyond our required sum, stop. Okay, and over here, now let us try to run this. It should again give us the right answer. It is giving us correct answer. Let me submit, and it got accepted. So both these solutions got accepted. You can use any base condition. The important thing is you should be able to identify that what all base conditions are going to be there. Where should I stop? Obviously you should stop when you reach your answer. Obviously you should stop when you are exceeding your answer. Obviously you should stop when you exhausted I, basically your I reached 10. So these are the only two cases we are stopping, right? These are the only three cases we are stopping. One, we reached the answer. Second, we exceeded the answer. We should not go there. Stop. Third, our I exceeded the limit. These are three situations where we are stopping. So just think in terms of these three possible situations, and you will be able to figure out the base cases. Okay. So I hope you will make a summary of this lecture as well and put it in the comment section, and you enjoyed this lecture. In the next lecture, we will see a very interesting problem again. So see you there. Bye bye.